Good morning, my friends. What we're going to do now is 6-3, number 3. Make sure you have it out. And I know it looks overwhelming, but we're going to just break it through one piece at a time. Okay, here we go. They say let f of x be the integral from 2 to x of f of t dt. You are on the graph of -2 to 6, consisting of two line segments and a quarter circle. These are important things because, one, the fact that they're stating to, I'm not guessing, that it's a quarter circle is helpful. The next piece of information I'm really excited about is when they give me a number at this part of the integral right there. That is their code way of saying you have the point to 0. Their reasoning of how that works, if I have the integral, that integral means the area under the curve. If I go from 2 to 2, that sounded funny, but you know what I meant, that there is no area. Whatever that rectangle is has no width, so the area would be 0. So that's your fun fact. They're never going to say, here's the point, congratulations. You have to take that piece out of there. All right, so starting here, they want to find f of 0 and f of 4. So I will make an integral of what I know to where I'm going. I'm going to start with 2 to 4. So you'll write an integral from 2 to 4 of your f of t, and you use the lowercase t. And then when you've taken the integral, it comes out, and that's how you show that it is the capital T. So now we are going to learn that this means we're looking at f of 4, and then the f of 2, that we just found out was 0. So this makes our life super easy. Now, 2 to 4. Over here, this is a length of 2, this is a length of 2, and you're sitting in a quarter triangle, so you'll use this formula. So 2 squared is 4 divided by 4. You're going to end up that this is an area of pi. So you'll be able to say if this area from 2 to 4 is pi, and that if f of 2 was 0, you now know f of 4 is pi. Yay for you. Okay, now let's go down to the colors so our life is less stressful. If I'm going to go 0 to 2, okay, so thinking about information that we know here, technically I want to start with that 2 down here, 2 to 0. Well, that looks silly. So the rule that we're going to pull from that one is that I can take the flip of these, but it would be negative. Very exciting information. You'll be excited in 10 seconds. Now, from 0 to 2, it is now a triangle. Yay, triangles. So I have 1/2 times base times height, 1/2 times 2 times 2, that this area is 2 right there. So f of t dt. So when I find out that I have f of 0 here, because the f of 2 is going to be making that the 0. So I'm going to say that f of 0 is -2. All right, there we go. So that was the area under the curves working with the 1 point. Let's see what we have for part B. Determine the interval where f of t, not the function that we're looking at because this is f prime or lowercase f, where that is increasing. So I'm going to use, by that definition, we will say f of x is increasing, and we're going to be looking from, if the derivative is above the x-axis, then the original function was increasing because the slopes are positive. So you're going to say 0 to 4. You could also write it this way. And then 4 to 6. And you could also write it this way. Hi, sorry, I had to get the door. So we're going to say f is increasing because the derivative is above the x-axis. Thing I don't think I made a point of, that we do have to go from 0 to 4, and then say 4 to 6 because of that cusp situation there. All right, let's move on. Find critical points and then determine if each corresponding is a relative minimum, maximum, or neither. Justify your answer. Let's us get a new color. Not this hard of a choice, but it is for me apparently. I'm going to go here, and I want you to underline this to make sure that you write me words. So, I need my picture. We are going to identify that there is a critical point at 0 and that there is a critical point at 4. Critical points, first derivative is equal to 0. This is my first derivative graph. All right, so let's first start with x equals 0, x equals 4 are critical points. We're going to say deriv equals 0. Next, we want to look at each of those. I have a lot going on, so let me erase some of this so we can have it easier to identify. Okay. Looking back here, we have this critical point. It goes from negative to positive, going down, then up. If I think about it, that's going to be a local min. So I'm going to come down here and I'm going to state x equals 0 is a local min because the derivative changes from negative to positive. You cannot say it changes. You need to tell me what is changing. Now, let's go back to the 4. The 4 is positive to positive, so that's not going to count as a max or a min. It's not changing. So you will say that x equals 4 is, come on 4, looks like a 4, is neither, no change in derivative sign. Okay, beautiful. All right, now find the absolute extremas, the x value and the x value pair, and justify your answer. Yay us. Okay, so we've already gone through, and let's see what we have for information. Now, find it very interesting? No, this is what they're going to do. They happened to ask you about 0 and 4. It seemed random when we started, but those were our critical points. So that was nice of them. We already did some work there. Now, when we do this, we're also going to be working, extremas means endpoints as well. So we're going to make a table. I want another color, so I'm going to fix that. So this is all color coded. So I need to do the endpoints and my 2 critical points. And from the information that we found in A, that's -2, that's pi. Come here, picture. So 4 to 6, woo, that's a big triangle. Here we go. 2 by 4 by a half is going to give me 4. So we were at pi. We're going to add that on because it's increasing because it's above the x-axis. So that's pi plus 4. Now we got to go the other way. Boop, boop, boop. All righty, here, look at this friend. Boop, boop. Now it's another 2 by 2 triangle, but you need to notice it's below the x-axis, which means, and pardon also means, when we were here at 0, we have that local min, right? Yep. So if we have that local min, that means it had to come down from somewhere. So even though this is below the x-axis, we're going to technically add on the value of 2. And we could write an integral for that, but I think this will be better just to have this. So let me recap that, and then we'll get into it again of why. This made an area of 2. This area, the area amount, will always be a positive number. The location being below the x-axis means it's a -2. And then based on the fact that it's a min, it means that it subtracted 2 from the point beforehand. So that's why we had to say that it was at 0. All right, now what does that mean for us? So we're going to have an absolute maximum at the biggest number. This is my absolute max. And then we're going to have an absolute min all the way over here. Now let's be careful of what they want. They want to know what the absolute max is. The max is 4 plus pi at x equals 6. The min is 0 at x equals -2, making sure you tell them both parts of that. Okay, point of inflection means second derivative set equal to 0 and then checking around it, of course, right? So we're now going to go look back at our picture. You guessed it, I am going to get a new color because it makes me happy. And then we're going to look at what is happening of where the second derivative is going to be positive. This is pretty. Okay, so as I look here, second derivative equal to 0, I'm going to be right here and here. And you may be saying, Bowen, lost your mind. Right, those are both cusp situations. So second derivative equal to 0 or undefined. We just don't say it because it's less exciting. So 2 and 4, then we're going to check. This one is increasing and then decreasing. Changes concavity, so that's an actual point of inflection. This one is decreasing, then increasing. The slope here would be negative. The slopes here would be, you can't see, sorry. This, then this, negative. So both of the possible inflection points are actual inflection points. So we will say, all right, x equals 2 and 4 are inflection points. Derivative changes sign. So we can say that the concavity has changed. Oh, good. Concavity is coming up right now. All right. Determine the interval where f of x is concave down. Justify your answer. Cool beans. Let's look. Now, do not look at your actual picture and thinking of that concavity. You're thinking of where this thing is moving. So, if the second derivative is negative, then it's concave down. If this is the first derivative, we want to take the slopes of this. And so the only section where the slopes are going to be negative is right here. These slopes are going down, so that means that my derivative is negative, and that means that the original is then concave down. All right, so we're going to say 2 to 4 is concave down. Reasoning. First derivative is decreasing. Sorry, F's having issues. All right, now you're going to have a great time enjoying working through these problems. I'll see you on Thursday. Have a wonderful, wonderful day.